This section on proving trigonometric identities involves proving that two expressions are equal. Generally, we manipulate only one side of the equation, but there are cases where we need to manipulate both sides of the equation. In this example, we are required to prove that sin x plus cos x, all squared, plus sin x minus cos x, all squared, equals 2. A general rule of thumb is to manipulate the more complex side of the equation. The right-hand side of the equation is 2, so we can't do much there. Thus, we will simplify the left-hand side. We start the problem by multiplying out the brackets. Sin x plus cos x, all squared, equals sin squared x, plus 2 sin x cos x, plus cos squared x. And sin x minus cos x, all squared, equals sin squared x, minus 2 sin x cos x, plus cos squared x. Simplifying that gives us 2 sin squared x, plus 2 cos squared x. We can now take out a common factor of 2, from both terms. Sin squared x plus cos squared x, equals 1, which means that the left-hand side equals 2, which equals the right-hand side. Prove that 2 over sin squared x, minus 1 over 1 plus cos x, equals 1 over 1 minus cos x. Again, we will start with the left-hand side. Sin squared x equals 1 minus cos squared x. We can now factorize 1 minus cos squared x, as 1 minus cos x, times 1 plus cos x. Since we have two fractions with unequal denominators, we need to find a lowest common denominator, which in this case, is 1 minus cos x, times 1 plus cos x. We therefore multiply 1 plus cos x by 1 minus cos x, and we do likewise with the numerator of the second fraction. Thus, the left-hand side equals 2 over 1 minus cos x times 1 plus cos x, minus 1 minus cos x, all over 1 minus cos x times 1 plus cos x. And now that the denominators are equal, we can add the numerators together. Simplifying, we get 1 over 1 minus cos x, which equals the right-hand side. As mentioned earlier, there will be times when we need to manipulate both sides of the equation. This problem is one of those times. We will start with the left-hand side, since it contains the quotient identity, tan theta. There isn't only one way to manipulate an expression. The more problems you do, the more adept at manipulation you will become. So, we will start by expressing tan theta as sin theta over cos theta. 1 over sin theta over cos theta equals cos theta over sin theta. Since the denominators of the two fractions are identical, we can add the two numerators and express the result as a single fraction. Thus, the left-hand side simplifies as 1 plus cos theta over sin theta. Provided you do not violate any mathematical laws, you may manipulate any which way you wish. Since we have simplified the left-hand side of the equation, we now have a new aim, which is to prove that 1 plus cos theta over sin theta equals root 1 plus cos theta over 1 minus cos theta. Again, there isn't just one way to manipulate a problem, so provided we do not violate any mathematical laws, we can manipulate this new expression again. So, in order to remove the square root bracket, we will square both sides of the equation. The new aim is now proving that 1 plus cos theta over sin theta, all squared, equals 1 plus cos theta over 1 minus cos theta. Looking at the new aim, it would be easier to work with the left-hand side, given we can multiply out the brackets in the numerator. The other alternative is to manipulate the right-hand side, but this is a little more tricky, so we will manipulate the left-hand side. Instead of multiplying out the brackets in the numerator, we will simply express 1 plus cos theta, all squared, as 1 plus cos theta, times 1 plus cos theta. The reason for not multiplying these brackets out, is because we require 1 plus cos theta in the numerator, on the right-hand side. Now, you may be asking, how do I know to do that? The answer to that question stems directly from what you are required to prove. Since we require 1 plus cos theta in the numerator on the right, we deliberately did not multiply out the brackets in the numerator on the left. Likewise, since we require 1 minus cos theta in the denominator on the right, and the denominator on the left is sine squared theta, we need to relate sine squared theta to cos theta somehow. Knowing how to manipulate a problem is a skill that you will acquire the more problems you do. Sine squared theta plus cos squared theta equals 1. Thus, we can express sine squared theta as 1 minus cos squared theta. We can factorize 1 minus cos squared theta as 1 plus cos theta times 1 minus cos theta. And now we are able to cancel identical brackets, leaving us with 1 plus cos theta over 1 minus cos theta, which equals the right-hand side. Again, there isn't only one way to manipulate a problem. The best way of tackling these identities is to keep everything as simple as possible. Since we were given an expression that involved a square root bracket, we manipulated the problem by squaring both sides of the equation. The result of this was to give us a different aim. We can manipulate like this because we are applying the same operation to both sides of the equation. The more you practice proving identities, the more adept at manipulation you will become. The Grade 11 workbook contains more ways to prove this identity. The important thing to bear in mind is that you find a technique that works for you.